decision coverage, how to coverage, how to calculate decision coverage, and the decision table as well. Okay, so I hope that you don't have any issues with these modules. Even if we'll just explain it one more time. So basically, what is the formula for decision coverage is number of decision exercise. So say for an example, there were 4 decision, 5 decision, or 6 decisions in a particular test case, wherein a total number of decisions means how many decisions were there total in total. So say for an example, in this case that we saw the examples over here, we do have a 5 total number of statement, that is in total. And number of exercise means what? First is read A, then it read B, then goes to the condition, then condition, after checking the condition it goes to the conclusion, because the conclusion is happening A is greater than B, right? And in the end it is also exercise the end if option. It goes here, but it does not execute anything, because there is no option. C is greater than equal to 0, it means A is greater than B, which is 15, right? So without wasting any time, we'll just take it. So total number of decisions is how much? Say for an example, as per that particular example, total number of decision was 5, and the number of decision is exercise is also 5. So 5 divided by 5, 5, okay, and then into 0. So 100% will be the decision coverage. Okay, so similarly this particular example I have shown you in the assignment section, so you have to complete it. Okay, next, moving forward, we are going to learn today what is control flow graph. Now what does that control flow means? Control flow is, guys, whenever a software is being developed. Now first I will talk about the development, then I will go to the testing part. So whenever a particular software is being developed, there are certain flows that how a software will be operating, how the function will be operating. This is known as the control flow graph of a particular software, wherein we design the flow of that particular software, that okay, clicking here, what would will navigate to the next section, then it will go further, right? What will happen after clicking this button? So this is known as the total flow of the graph. Once clicking on the login button, it will ask us to enter our ID or register. Then once we enter our credential, once we enter our details, then it will ask us to it will trigger an OTP, wherein we have to verify that OTP and click on verify. So this is a particular flow, that how a software or a button or a particular module should operate. Now in the control flow graph, the procedural design of the program can be converted into control flow graph, that okay, entire things how it is going to be functioned. Now next is contains various entities to define graphical structure. First, which is edges. Okay, so these are known as edges. Say for an example, if you say that okay, we do have a square kind of shape. So in the square, left, right, up and down, these are the edges. Nodes are what? Circles representing one or more action. Node represent either a statement or a condition. So a node will represent, if there is a small circle, which will represent what? Either it will represent a particular number, which can be a is equal to 15, or a kind of a condition that we applied in the software, if else, anything, right? So this is known as the dots of a particular software or particular control flow graph. This is known as control flow graph. Regions are what? Areas bounded by the edges. So these are the edges, okay, and this is kind of rounded, so it is protected under the edges, right? There are 1 edge, 2 edge, 3 edge and 4 edge, and those edges are protecting what? Regions. So a region contain many edges. Predicted nodes, a node containing a conditional statement or having more than one outcome. So say for an example, predicted node is this one, wherein it says that users would be able to log in. Now the user can be able to log in using phone number, the user can be able to log in with his email ID, and then whatever the final execution, it will executed. So this is how the control flow. Before developing a software, before testing a software, we should know what is the control flow or what will be the control flow of a particular software. So once we know that which option will indicate which particular page or which particular functionality, then only we'll be able to dedicate or basically dictate that what is the defect or is there any defect or not, because until and unless you don't know how a software function, you won't be able to come out with defect or bugs, correct? Let's move next path, which says path testing. Now path testing is what? When white box testing take place, we strive for path coverage. Now we learned here about the decision coverage, right? Now we are going to learn about the path coverage. Designing series of the test cases, ensuring that every statement in the program get executed at least once. So similar way, we can take the example of this particular test case. First read A, then read B, then applies the condition, then goes to the condition. Okay, first it applies, do the calculation, then it goes to the condition. Basically it check the condition meet the eligibility criteria or not. If it is, it will print C negative, or else it will go to end if, and it will end the program. So this is what each of the series are called path. Okay, so this is known as the path coverage. Conditional logical execution on true or false, as we saw, right? Also called the basis path testing or MCAP testing, MCCAP testing or MCAP testing. Now what does it mean? Thomas McCabe introduced a method of mapping the structure of module graphically for developing a test cases easily, because once we know that what is the control flow of a particular software, we'll be easily able to easily able to write the test cases, plan the test cases, and do testing. How? Because this is the main function we know. Under this main function, how a main function should operate? It should operate either with a phone number or with an email address, right? So this way we are able to guess that how the software will function. Making sense? Perfect. Next says calculate cyclometry complexity. Okay, now cyclometry complexity, what is that? We'll learning in the next one. Choosing basic set of path and generating test cases to exercise each path. Now let's come to the cyclometric complexity, wherein it says the three methods to find cyclometric complexity. Number of predicted nodes, this one, which starts from the very beginning, the main module. The number of closed region plus one. So these are the closed regions plus one. Or cyclometric complexity, which is E. It means edges. N indicates nodes, and 2 plus 2. So plus 2 is what? Plus 2. This is the formula basically to calculate cyclometric complexity of a particular software or a particular control flow. Okay, so what we're gonna do after calculating this cyclometric complexity? Basically we will be able to come out with the result, the actual decisions, the actual path of that particular software, that okay, this is how the module will be tested and the test cases will be designing, and this way the software should operate. Making sense? Find cyclometric complexity of the shown graph. Now we'll just take an example just to understand it in a better way. So say for an example, this is nodes. What this is node or predicted node. So we'll call it a predicted node. Okay, so this is what? This is a predicted node, which means that it is the main function. Okay, now what is the main predicted node here? Let's take an example of login. Okay, login button. Okay, now under login there could be many possibilities, like first it will be with the phone number, then it will be with the email ID. It should contain a verified OTP section. Both the sections should contain what? Verify OTP, correct? And then further it will be process. So basically this is what? This is a predicted nodes. Okay, regions are what? Regions are basically, this is the region. This will call the region of a control flow graph of a particular software, because it is what? It is surrounded by edges. Now what are edges? These are the edges of a cyclometric complexity. So say for an example, we came to login in simple language. We are testing login module. So we have to draw the control flow graph. Why we need to do that? We'll be able to understand that what are the regions, what are the edges. So once we know, we'll be able to say, okay, so the main goal is to reach to the main page of a particular software wherein we can purchase a particular product. Correct? Now in order to do that, what we should do? First we should log in with our either with our phone number or our email ID. then both will trigger a OTP to a registered number or to a registered email, and then we should verify that particular OTP. Once this process is done, then we'll be land into the main page wherein we will be able to add product. Correct, we will be able to buy. So in order to achieve this particular goal, we should understand, we should draw a complexity basically, or cyclomatic complexity, in order to know the control flow, the software flow, that how it should function, right? So if you are going to test the main buy page or buy now page, or what we call it a checkout page, then we should follow these steps. This is the flow that we have to do, we have to go through, so that we can better design the test cases, right? Hope you are able to understand this particular cyclomatic complexity. Moving further, path coverage. So how do we calculate path coverage? Now define as a flow of execution from starting of the program till the end of the program. Okay, so from starting path till the end path. Path coverage, percentage of the path that has been exercised during the test case execution. What is the aim of doing a path coverage testing? Well, to exercise every path of the program at least once in testing, right? So if you are testing an entire module, so each of the path of that particular module needs to be tested at least once. Equation, path coverage equation or calculation will be number of path exercise, same, and the total number of path into 100, which will lead us to the actual percentage of a path coverage. Now, how we will be able to find the path coverage? So here is an example. Now to find int means integer. Guys, if you don't know, let me know, okay, in the comment section, so that I can reply you back. So basically guys, int denotes integer. Integer denotes any kind of number in a form of decimal, like numeric. So this is known as integer. And character is known as what? Varchar. It is known as the alphabet order. So whenever we are considering a is equal to 15, then we have to take the character, we have to take the integer for the number. So here it is says to find int is meant integer x and integer y. If x is greater than equal to 0, then print x is positive. Else if it is not, then print x is negative. Okay, this is the first statement. So let's take this example. It says x is equal to greater than 0, then positive or negative. So basically guys, we are here to find out. So say for an example, let's consider that the value of x, we must have read that in a once in our lifetime. So x, value of x, say for example, value of x is 5 here, okay, and the other what is this? It is y. So y is equal to 6, okay, y is equal to 6, x is equal to 5 and y is equal to 6, okay. Now it says that if x is greater than equal to 0, so what is x? X is 5, right? So is it greater than 0? Yes, of course it is greater than 0, then it will be true. So how it will be? X is greater than equal to 0. How many conditions are there? How many paths are there? So basically either it can be true or it can be false. Make sense? So in order to get that, what we can see here, that it will print x positive. So here we will be able to, similarly in the y as well, okay. So it says t1, x is equal to 12, y is equal to 5, x is equal to -1, y is equal to 35, okay. So how many paths are there if you see this? 1, okay, first it is doing to find, then 2, then 3, then 4, then 5, then 6, then 7. Now you might have a question that why this else is not included. Well, that is because it's a condition. If this particular condition not met, then only this particular point will be exercised, right? So it is says how many paths total are there. So their total path we will be calculating the total number of decision, the total number of path or statement that we have, will be calculating that, will be counting that, as well as number of path exercised. It means how many path exercise. So first is ask, okay, that find out this value, then it goes to the condition. After going to the condition, it found that okay, age is greater than 0. Correct. So it will print X positive. So we don't have to print this thing. Do we need it, guys? We don't, right? So else will be avoided. Next it will go to the second one, 1 2, then it says y is positive. Y is equal to greater than 0. So in the both statement, y is also greater than 0 and the x is also greater than 0. So again it will do the same, 1 2, it will print. Okay, so the total number is 1 2 3 4 and exercise 1 2, right? So find statement, decisions and path coverage. So we learned about decision coverage, we learned about the statement coverage and the path coverage. So you have to find out that what will be the path coverage percentage in this given statements. So I will be giving that in your assignment sections and as a practice test. With this, guys, our fifth module is also completed. Okay, next we'll be moving ahead with the test management. So basically, what are the things in the test management? So let's go out with the topic, then we'll be jumping to the main module. So test plan, we will be learning what are the strategies of testing a software, what are the risks involved, product risks and project risks. Okay, likelihood and impact of risks, approach to tackle the risks, risk based testing, risk analysis template. Basically template is nothing, it is that how we are going to do that. Incident management, incident are what? Incident are basically a kind of a what we can say, incident are basically a kind of a event. Okay, now the event can be with many types of, okay, incident report life cycle, that when the incident happened, how it happened, what is the state of the incident, and component, what is the criticality of the incident, components of incident report life cycle. So these are the things that we'll be learning in this topics, which is what? Test management. Along with this we'll be learning the test strategies. So till then practice and just practice so that you can be a good tester. That's the main goal, right?